All right, in this video, we are going to be talking about implicit differentiation. Here, so far, we've talked about explicit differentiation, aka we've solved something for y. So it's always y equals something, y equals something, y is equal to something, and we take the derivative of that with respect to x. Sometimes, though, we have functions that aren't explicitly defined with y equals. So think about like conics with your circles and your hyperbolas and whatnot. You'll have to solve for y, but if you solve for y, that sometimes get messy. So we kind of need a way to take the derivative without really solving for y. So to do that, we're actually going to be using chain. Lots of fun. Because we're assuming that y is defined implicitly as a differentiable function x. So looking at number 7 here, we have the derivative with respect to x of x to the third power. Since we're taking the derivative with respect to x here, we're going to have 3x squared times, and then we're going to use chain. That's going to be dx over dx, which is technically 1 or 3x squared. Number 8, though, notice how here we have y to the third power. So I'm going to use regular power rule. That's going to be 3y to the second power. But then, because I have this y right here, I'm going to use chain. But if I use chain, I'm going to have the derivative of y with respect to x. So that's how we get dy dx, or y prime. Same thing with number 9. If I take the derivative of x with respect to x, that's just going to be 1 dx over dx, which is just 1. And then if I take the derivative of y, that's going to be 1. But then remember, I have to use chain now. So then I have dy dx, or 1 plus y prime. Same thing with number 10. I'm going to use product here. So I'm going to have first times the derivative of the second. So I'm going to have 2y. And then using chain, I'm going to have the derivative of y with respect to x plus second times the derivative of the first. So that's going to be 1 dx over dx. I'm going to clean this up a little bit so that you can see that this is just going to be 2xy, y prime, plus y squared. Now, these couple examples were kind of easy peasy lemon squeezy. These next couple examples, though, are not. They're kind of fun, though. So let's see what happens. So what we're going to do is differentiate both sides with respect to x. We're going to collect all terms involving dy dx to one side of the equation. Then we're going to move all the others to the other side of the equation. We're going to factor out dy dx if we need to, and then we're going to solve for dy dx since we want to find the derivative. All right, so here for number 11, I have y cubed plus y squared minus 5y minus x squared is equal to -4. And if I take the derivative of y to the third power, I'm going to have 3y squared using regular power. Then if I were to take the derivative of y with respect to x, that's just going to be dy dx, or once again, you can shorthand this, which I'm going to do from now on, y prime. Same thing here with y squared. I'm going to take the derivative of that. So that's going to be 2y, and then y prime. The derivative of -5y is just going to be -5y prime. And then we have the -2x, because that is my derivative for x squared. And the derivative of -4 is just going to be 0, so I'm going to have equal to 0. All right, so step 2 says collect all terms involving dy dx to one side of the equation. Notice how all of my dy dx's, my y primes are on one side. All I have to do now is just technically move the negative 2x to the right side. So that's going to be all of this. But I have the 2x on the right side now. Then what we're going to do is factor out the y prime. So I have y prime, 3y squared plus 2y minus 5 is equal to 2x. And then if I take the derivative, well, if I solve for the derivative, I'm going to, I am going to divide by 3y squared plus 2y minus 5. And this right here gives me my derivative for number 11. Lots of fun. All right, number 12. I'm going to take the derivative of 2y. That's just going to be 2y prime. The derivative of x squared is 2x. And then the derivative of sine y, we're going to use chain, is cosine of y. But then the inside, the derivative of y is just going to be y prime. Our next step is to collect the y's. So I'm going to move the y prime over. Then I'm going to factor out the y prime. And then I'm going to divide. And I get 2x over 2 minus cosine of y. All right, one more, and then we'll get to some more complicated ones. Actually, let's do 16. All right, number 16, you might think, okay, we probably want to use chain and then use chain even more. But I'm going to give you a hint that we're not going to do that. Instead, what we're going to do is take the square root of both sides because we have this 2 right here. Taking the square roots will cancel out this 2 right here, and we're just left with sine of pi x plus cosine of pi y is equal to plus or minus root 2. And the thing is, the derivative of plus or minus root 2 is just going to be 0, so that's why we did that. We are going to take the derivative of sine pi x. That is going to be cosine pi x. And then, of course, we're going to take the derivative of pi x because that's my inside function. That's going to be pi. Then we're going to do the same thing for cosine of pi y. The derivative of cosine pi y is going to be minus sine pi y. And then we're going to take the derivative of pi y, which is just going to be pi and then y prime is equal to 0. I'm going to move the y prime over. And then I'm going to divide by sine pi y times pi. I'm going to move the pi up front. Which gives us my derivative to be cosine of pi x over sine of pi y. Yay! Now, as a fun exercise, what we're going to do is actually use chain within chain and see how this is going to be equivalent to what we just found. All right, so if we do that, I'm going to have 2 times sine pi x plus cosine pi y is equal to, well, let's not do that. And then what we're going to do is use chain. So then we're going to take the derivative of this here. And once again, that's going to be cosine pi x times pi. And then we have minus pi sine pi y prime is equal to 0. Okay, this is a mess already. I don't like it. Here's the thing though, if I were to isolate y prime, since all of this is a product, I'm going to divide everything by 2 sine pi x plus cosine pi y. And since it's being divided by 0, it's just going to cancel out. Crazy. I know. So this is going to cancel out. And then we're left with cosine pi x times pi minus pi sine pi y prime is equal to 0. And this is where we started out on number 16. So either way, whatever you prefer, whether you want to use chain twice and do that, you can. Or think about, hey, we could take the square root, because either way, this is going to be 0 whenever we take the derivative of that and call it a day. So once again, just thinking about tips and tricks on making your life easier whenever you guys are taking these derivatives. All right, in the next video, we are going to talk about applications. So these are going to be the equation of tangent line problems and all of that good stuff. Oh, and we get to do the 2024 AB5 problem. Lots of fun. I forgot that I updated.